Well, here I really need to confess that I only shown you this type of a situation just once. If you remember, well, we did a problem that was, I think it was for 10 marks. The one that we had to do a back titration. This is a back titration type of a situation. So I've only shown it to you once, but nevertheless, let's give it a good look. So here they say a school laboratory has 100 cubic centimeters of hydrochloric acid solution with a concentration of 0.9 mole per cubic decimeters, which is available. So we are given the volume as well as the concentration, so we can find the number of moles. Well, we are just going to skip that one for the time being because it's very easy to find the moles anyway. Now they say all of the 100 cubic centimeters of hydrochloric acid solution, all of it is allowed to react with 3.5 grams of an unknown metal carbonate. So we don't know what is the metal M. According to this balanced chemical equation, so we have 1 mole of this metal carbonate reacting with 2 moles of hydrochloric acid in order to produce 1 mole of this metal chloride, as well as 2 moles of water and 1 mole of carbon dioxide gas. But here they say to us, the hydrochloric acid solution is found to be in excess. Very, very important. It's an excess reagent. Now they say to us, the excess hydrochloric acid, in other words, the one that remains after it reacts with this metal carbonate, is neutralized by 25 cubic centimeters of a sodium hydroxide solution having a concentration of 0.8 mole per cubic decimeters. The neutralization reaction of the excess hydrochloric acid solution is shown here. So we have 1 mole of sodium hydroxide reacting with 1 mole of hydrochloric acid in order to produce 1 mole of sodium chloride and 1 mole of water. Now the question is asking us to determine, by means of a calculation, the symbol of the unknown metal, M. Okay, well, this is a very good question. Now here we can see that we are dealing with a back titration type of a situation, because we said in a back titration, you'll be reacting 2 reactants, and one of those reactants is going to be remaining, the excess one. Then you don't want it to remain, no? You now react it with a different substance. That is a back titration. Now the question is, what do we need in order to determine this symbol of the unknown metal? What is it that we are actually calculating? That's the big question. Well, every time in quantitative aspects, when they ask you to perform a calculation in order to identify an element, they're actually asking you to find the molar mass of that element. So the question is, how do you find the molar mass? Well, all that you need is to find the number of moles, because you are already given the mass of this metal carbonate. Do you see that? So what we need to do here in simple language is to determine the number of moles of this metal carbonate that are needed to react with hydrochloric acid. So that's what we need. Now, from this 100 cubic centimeters and 0.9 mole per cubic decimeter of hydrochloric acid, we are actually going to get the available number of moles. Now that we know hydrochloric acid is the excess reagent. All right? So we get those that we had at the start, the available moles. Then from the last reaction, we are going to use information about sodium hydroxide, that 25 cubic centimeters, and the 0.8 mole per cubic decimeter, in order to find the number of moles of hydrochloric acid that are in excess. Now that we know the moles that are available at the start and those that are in excess, then we can find those that reacted with this metal carbonate. Then we now know the moles for the metal carbonate. Then it's very easy to find the mass, well, the molar mass of this metal carbonate. Okay, first things first. We need to calculate the number of moles of hydrochloric acid that are available at the start of the reaction, all right? So in order for us to find those, we have to define the concentration. Well, actually, we would have found these moles from the previous question, but since we didn't do it, then we need to do it now. So concentration equals number of moles divided by the volume. All right. Well, they told us that the concentration is 0.9. We need to find the moles, and we know that the volume is given to us in cubic centimeters, and we have to convert it to cubic decimeters by dividing with 1,000. So we get 0.1 decimeter cubed. And now if we cross multiply, we find that the number of moles of hydrochloric acid that are available at the start of the reaction will simply be 0.09 moles. Okay, fine. Then now we need to find those that are in excess. And in order for us to find them, we are going to use sodium hydroxide. And once again, with regards to sodium hydroxide, we are given the concentration. So we define the concentration once again as the number of moles divided by the volume. And the concentration of this one is 0.8. We are looking for the moles, and the volume is 25 cubic centimeters. We need to divide it with 1,000 in order to get it to the cubic decimeters. And when we do, we get 0.025. So when you say 0.025 times 0.8, we find that the number of moles of sodium hydroxide will simply be 0.02 moles. But then from the balanced chemical reaction between hydrochloric acid and sodium hydroxide, we can see that the mole ratio is 1:1, which means that the number of moles of hydrochloric acid that are in excess are exactly equal to the number of moles of sodium hydroxide, which are just equal to 0.02 moles. Okay, so now we know the number of moles in excess. We also know those that were available at the start of the reaction. And we know that the number of moles in excess are equal to those that are available minus those that reacted with something else or used to react with something else. In this case, the the metal carbonate. Hey, I'm not sure where the sodium comes from. So what? From this equation, we can see very much clearly that if you want to find the number of moles that are used, you just need to take it to the right-hand side, the left I mean, and then you take those that are in excess to the right-hand side, which means that the number of moles that are used, I'll just write it here, are equal to those that are available at the start minus those that are in excess. So if you find the difference between those two, you find that the number of moles that reacted with the metal carbonate will just be 0.07. However, you need to be careful, very, very careful, because according to the mole ratio, that's not the number of moles for the metal carbonate. This is what we need for hydrochloric acid, but it's not what we need for the metal carbonate. Why? Because the ratio is not 1:1. It's not the same as this sodium hydroxide and the acid. So now you have to tell them that the ratio between this metal carbonate and the acid is actually 1:2. So what does it mean? It means if I have 0.07 moles of the hydrochloric acid, how many moles do I need for the metal carbonate? I actually need half of what I have for the acid. This one divided by that one multiplied by that. So this means the number of moles of the metal carbonate is simply going to be 0.035 moles. Okay, fine. So now we know the number of moles for the metal carbonate. We were also given the mass of this metal carbonate. Now we just need to find the molar mass of the entire metal carbonate. Well, this one you can do it in one of two ways, really. You can choose to find the molar mass itself, or you can choose to substitute into your molar mass. But bottom line is we know that the number of moles are these. The mass was given to us as 3.5. Now we just need to find the molar mass. Well, I'm just going to extend this and say, what is the molar mass of this thing? Well, I don't know what is the molar mass of my metal, but for carbon, I know it's 12. For oxygen, I know it's 16. So if you add those together, you simply get a 60. Remember what I said. You could have decided not to do this and just find the molar mass itself, then subtract after finding the molar mass. Well, I think that's the easiest thing, honestly. Let's just stick to simplicity. Someone said simplicity never runs out of style. So Yeah, let's be simple. So if you want to make the denominator to become the subject, you just take what was the subject and make it the denominator, and then take the denominator and make it the subject. So now if you go to your calculator and say 3.5 divided by 0.35, you find that the molar mass of the entire compound, this entire metal carbonate, will be 100 grams. But you know that this compound is made up of the metal M, which is having an unknown molar mass, and carbon as well as the 3 oxygen atoms. Their combined molar mass is 60, which means that the molar mass of the element M will just be 40 grams per mole. Okay. Which element in the periodic table has a molar mass of 40? Well, you can quickly look it up, but this is calcium. So now you can conclude and say, therefore, M is equal to Ca, because the question is asking for the symbol. It's not asking for the molar mass. If you just leave it at the molar mass, you may get 6 out of 7. The question